So let's examine this divide and conquer code, which is in front of you. I will uh, urge you to look at just this part. और अगर आप इस part को देखते हैं, it's really just a carbon copy of merge sort, except for these return values. Okay, yes, these return values were not there in merge sort. It was just sorting the array. But here, again, we make the left call and we make the right call in a post order fashion, meaning first we make the calls and we compute a mid using left and right, then we make the recursive calls और हमें लेफ्ट का आंसर मिलता है जो कि हमें L1 R1 और S1 ये थ्री ट्यूपल मिला लेफ्ट से और राइट से हमें ये थ्री ट्यूपल मिला और अगर लेफ्ट लेस देन राइट होता है और अगर हमें लेफ्ट लेस देन राइट नहीं है तो ये हमारा बेस केस होगा कि हमें साइज 1 की अरे मिल गई. Actually, I have missed one thing. In this case, when we get the size 1 array, we should do something extra. And I'm going to do that here in this part of the code. Okay, let me just reduce the size. So yeah, in the else part, this is when um, left is equal to right. Meaning, मैं divide करते हुए ऐसी arrays पे आ गया हूँ जहाँ पर अब left equal to right है. और इस point पे थोड़ा सा difference है merge sort से. जब merge sort को सिर्फ एक size की array मिलती थी तो it had to do nothing. We can't do nothing. We will have to here return something. And that return something will be there. Will be this. Left, left, A left. Or you could use right here if you want, because left and right are equal. So जो आपकी एक ही इंडेक्स है, जो आपका लेफ्ट भी है, राइट भी है, वही आपकी इस कॉल में लेफ्ट और राइट वही सब एरे आप रिटर्न कर दें. लेफ्ट राइट इंडेक्सेस उसकी वही रहेंगी और सम क्या होगा जो वाहिद एलिमेंट वहां पड़ा हो. ओके, सो अगर आप डिवाइड करते करते एक सिंगल एलिमेंट अरे पे आ गए तो you're just going to return the indices which are the index of that array as left and right and the value on that array as the sum. So that will be your base case. And if you're not in the base case, then you divide. And when you divide, you go to the left and you go to the right. The important thing here is this line. This is the critical line, and this is really the thing we want to understand about this algo, because the rest is just like merge sort. It's just the rest is just routine divide and conquer. What is max crossing array doing? I just showed you that it is possible that neither of these L1 R1 S1 and L2 R2 S2 are actually the optimal solution. And the optimal solution is actually an array जो कि middle को cross करती है. Okay, जो कि ना तो exclusively left पे है ना exclusively right पे है. तो हम एक function लिखेंगे यहाँ पे जो कि इस max crossing array को निकालेगा. और वो जो मैक्स क्रॉसिंग एरे है वो L3 R3 S3, लेट्स से वो L3 और R3 इंडेक्सेस पे पड़ी हुई है और उसका सम S3 है. और इस पॉइंट पे एक और लाइन होगी हमारी जो कि मैंने यहाँ नहीं लिखी अभी तक. वो ये है कि हमारे पास जब तीनों आंसर्स आ जाएंगे, लेफ्ट का बेस्ट आंसर, राइट का बेस्ट आंसर और क्रॉसिंग का बेस्ट आंसर. और बाय द वे ये रिकर्सिव कॉल नहीं है, ये एक फंक्शन हमें लिखना पड़ेगा जो कि बेस्ट क्रॉसिंग एरे निकाले. तो जब हम ये काम कर लेंगे तो यहाँ पर फिर हम सिंपली रिटर्न best of, you can write a function called best of, which is basically just going to return the max of these three things: L1, R1, S1, L2, R2, S2. Basically, comparison सिर्फ S values पे ही होना है, लेकिन जो चीज return होनी है वो सात indices भी return होनी. So L3, R3, S3. The best three tuple will be returned. A small coding note is that जब आप कोडिंग कर रहे होंगे तो I hope all of you can answer कि आप इस तरह का ऑब्जेक्ट कैसे बनाएंगे. You can make a struct containing three integers, right? L1, R1 and L, R and S, and then you can use that when you're coding. So ये function O of 1 में इनमें से जो maximum है best है वो return कर देगा. So हमने left भी देखना है, right भी देखना है और crossing भी देखना है. So now the question is, the scheme makes sense, and we will dry run it in detail in the last part. But the issue is, how do we write this function and how much time is it going to take? Because if I look at the rest of the algo, it's just the same as merge sort. You give an array of size n. That array is divided into two subarrays of size, not the array, but the problem is divided into two subproblems of size n by 2. Then their answers are combined using this function and this next function. Now these two functions, this max crossing array and this, well, best of is just O of 1. So it really depends iska kitna time lagega, max crossing array ka. So I can already write a recurrence for this algorithm, which would be something like this. In order to solve a problem of size n, I need two problems of size n by 2, just like merge sort. Plus, I need some time on this step, okay? And that time on this step, okay, is O of 1 for this thing, plus something for max crossing array. And let me just give you a flash forward. This is going to be an O of n log n algorithm. And we know from merge sort and solving some recurrences that if this is O of n log n, then this must be O of n, okay, or Cn. जिसका मतलब क्या हुआ कि हम लीनियर टाइम में मैक्स क्रॉसिंग array निकाल सकते हैं. So this is a challenge for you. If I give you an array and I ask you a different question, I'm not asking you to find the overall max subarray. I'm asking you find such a max subarray which is a crossing array. In other words, which passes through the middle of the array. Can you do that in linear time? If you can do that in linear time, then we have an overall scheme to solve the journal max subarray sum problem in n log n. So the question boils down to, can you find maximum crossing subarray in O of n? Can you write this function such that it gives me the best max crossing subarray and it works in linear time? Again, pause the video and take some time, maybe take 10 minutes, 20 minutes, 30 minutes, and solve this. Try to find a scheme that gives you a maximum crossing subarray. And remember, this array must pass through the middle. लेफ्ट पे एक्सक्लूसिव जो अरेज हैं उनकी बेस्ट हमारे पास ऑलरेडी है, हमें दोबारा देखने की जरूरत नहीं है. और वो अरेज जिनका लेफ्ट और राइट एंडिंग पॉइंट बिल्कुल राइट पे हैं दोनों, वो भी देखने की जरूरत नहीं है. हम सिर्फ उन अरेज को देख रहे हैं जो मिडिल में से पास करती हैं, क्योंकि वो अरेज अभी हमने नहीं देखी. और वो हमारा ये फंक्शन जो है, इसको हमें बताना है कि वो अरेज कैसे निकालनी है. So give yourself some 10-20 minutes and maybe less, maybe you'll just find it right now, and find the best array that crosses the middle. And then we will do it together. So pause and do it. So let me once again take the help of this example to explain to you how we can find the maximum crossing subarray. Remember that in this step, we get this answer from the left and we get this answer from the right. And this is the better answer, okay, but it does not turn out to be the optimal answer. How can we find the maximum crossing subarray? The bad way to find it would be कि यहाँ के हर starting point के लिए दूसरी साइड के सारे एंडिंग पॉइंट देख लो. मतलब पहले इतनी array चेक कर लो, okay, starting from this 3 and going to -2. फिर ये array चेक कर लो, फिर इतनी array चेक कर लो, फिर उसके बाद ये पूरी array चेक कर लो, फिर यहाँ से लेफ्ट को अपना लेफ्ट पॉइंट चेंज करो, यहाँ तक चेक करो, फिर यहाँ तक चेक कर लो, फिर यहाँ तक चेक कर लो. I mean, this will be O of what? This will be O of n square. We don't want that kind of work. But thankfully, there is a better way to do it. And the way is to realize that we have to pass through the middle. So let me write this line. This is the middle line, okay? Let me draw this line here. This is the middle line. And if I want to find out maximum crossing array, what will it look like? Well, that crossing array will have definitely one element on this side and maybe more. Similarly, it will have definitely one element on this side and maybe more. ऐसा नहीं हो सकता कि it has no element here, because then it will become an exclusively right array. Similarly, it must have at least one element here, right? So what I can do is I can think of my crossing array as containing two wings, a left wing and a right wing. And here is the thing, both of these wings must be the maximum possible sum starting from the middle to the end of the wing. Okay, so for instance, in this case, I have just 4 wings to check. One wing, this is the other possible wing, this is the third wing, this is the fourth wing. And I can do this in a single pass. I can say this is -2, this is 12, this is -2 again, जब ये सारा add होगा, and this is 0. Which wing is the best? This wing is the best. So I choose this. This is the right wing. I can do that in O of n by 2 actually. आधे हैं सिर्फ elements. And then I go to the left wing. So I just found the right wing. Left wing, which is, well, the wing up till here is 3. The wing up till here is -4. The wing up till here is 8. And the wing up till here is 9. So which is the best wing? This entire thing. This is the best wing. Again, in just n by 2 computations, I have found the best right wing, the left wing. So the best left wing is this much, and its sum is 9. And the best right wing is this much, and its sum is 12. So my best crossing array is 9 plus 12, right? It is, so actually its sum is 21. And its left point is the left point of the left wing, okay, which is index 1. Incidentally, data भी 1 है, but it's index 1. And the right wing is actually, the right point is the right ending point of the right wing, which is in this case 7. And this will be my L3R3S3. और अब वो जो बेस्ट ऑफ का फंक्शन है वो इन तीनों को कंपेयर करता है और वो कहता है जी ये आपका आंसर है, and I get the best answer. Now this is amazing because now it means that I can find a crossing array in just O of n. Let me just quickly do a like a recap. That this crossing array it just contains 2 wings, a left wing and a right wing, and both of them have to be optimal wings on that particular side, meaning I just have to accumulate the sum up till every endpoint. तो यहाँ तक है -2, यहाँ तक है 12, यहाँ तक है 2 और यहाँ तक है 4, whatever. मैंने अगर कोई पहले गलती की थी तो अब सही हो गई होगी. So yes, I think यहाँ मैंने 0 कह दिया था, but this is 4. So best sum यहाँ तक हम बस इसको नोट कर लेते हैं. O of n में इस तरफ चेक किया और O of n में इस तरफ चेक किया, ओवरऑल O of n काम, और आपको ये चीज मिल गई. So this is great. Now we can we can write, and this is an exercise. I'll leave it to you as an exercise. You have to write this function. It's not a difficult one, right? You can just write this function which works in O of n. So now we know this works in O of n, and these two sub problems and the rest of the O of 1 stuff together, they give you this. And we don't have to do any analysis for this recurrence. We have already done it. This is the same recurrence as for merge sort. So this is O of n log n. We have already done the analysis. Now in the last video, the next one, I'm going to just dry run this whole thing on an array, this array which I have here. Okay, and this is actually the tree that we will see. Let's see this in the next part. Just absorb the information I've given you so far, and then we quickly do the dry run, and then we will be done for this lecture.